Leo Tolstoy's Anna Karenina, it begins with this really popular line, all happy families are alike. Each unhappy family is unhappy in its own way. John Wheeler used to believe that black holes are like happy families. They're all exactly the same. He and Jacob Bekenstein came up with the phrase, black holes have no hair. And you've called John Wheeler one of the greatest phrase masters in physics. This is definitely a phrase that stuck because it became the premise for the no hair
He also
theorem.
invented the word black hole.
Multiple phrases
Black
that John
holes,
Wheeler,
black holes have no hair. He was, yeah.
John Wheeler can take credit to multiple phrases in physics. And this became the premise for the no hair theorem. So let's define all of these terms. What is the no hair theorem? What is hair in this context when it comes to black holes? And then what does it mean when he says, along with Jacob Bekenstein, that black holes have no hair?
Yeah, so if you look at two stars in the sky, you could have two stars which had exactly the same mass, exactly the same total luminosity. But if you looked at them with more and more detail, every star, there are millions, billions of stars up there, every one is different in innumerable ways. Every star has, trillions and trillions and trillions of atoms in it. And they might be different elements, and they'd be moving in different ways and different temperatures, and there'd be magnetic fields and all kinds of detail, right? Every star is different. But the weird thing about black holes is, according to the theory of general relativity, there are only two things that characterize an astrophysical black hole. That is its total mass, and they also spin. Right. One of the really interesting things about them, their mass and their spin. And if you have two black holes with the same mass and spin, they're exactly the same according to general relativity. And so you could have two stars which were very different with the same mass and spin. And stars can sometimes collapse under gravitational pressure under certain circumstances and become a black hole. So you could have two stars which were very different, and then they would collapse into a black hole, and what would be left of the black hole would be not just approximately the same, but exactly the same. And that, at least as far as we know how to describe this situation with general relativity, it tells us that they will be exactly the same. And I'm sure you'll ask me about that later. It's related to the information problem, but it's very troubling that two things which are different can become the same. And that's what John Wheeler meant by saying black holes have no hair. Yeah. There aren't distinguishing features classically on a black hole.
They're bald.
They're bald.
Right.
Yeah.